So awesome. Good gym, everyone. Um, so, so glad to have everyone online, and for all those joining virtually and residents, good morning. So we're here, and we'll be having the math sections, and Faith will be leading us on this subject. So, welcome, Faith. You have the floor.
Okay, thank you very much, sir. Good morning, everyone. Uh, I'm Faith Robert, and I'll be one of your mentors because of the boot camp. So today we'll be having the blockchain maths 101 session. Let me quickly share the screen. I have shared the slide on the Telegram group for this boot camp, so you can all go through it. Please kindly let me know if you can see my screen.
Yes, we can.
Okay, thank you. All right, so I'm just going to rush through this. Seeing we have the slides, please, it will do us good to go through the slide to get acquainted with what is going on here. So, blockchain math 101, we go straight to basic arithmetic and algebra. For the duration of this bootcamp, why we'll be taking math is for us to understand the mathematical part of blockchain and have like proper understanding of what is happening behind the scene, why it is important to understand this and to help ease our transition for those who are just transitioning into the blockchain space, to help ease our transition into blockchain development. Understanding the maths that powers these blockchain systems, cryptographics, and all of that will help us um, gain better mastery and would position us better in understanding what the blockchain is and how to develop using blockchain technologies. So why the math matters in blockchain? Math is fundamental to blockchain as it enables secure transactions, determines token distribution, and drives smart contract logic. So when I said it enables secure transactions, it is the math behind the blockchain that powers the calculation of nonces for each transaction that makes sure no particular nonce is the same. No two nonce are the same for every form of transactions to make sure that each transaction piles up over the previous transactions. And also for calculation of your gas prices, your gas fees, gas limits, token transfers and the rest. All these are done using mathematics. Also, when we talk about token distribution, You see that there are many airdrops platforms that distribute some percentage of their earnings to users and to some whitelisted addresses. They use maths to power that distribution algorithm. Also, for smart contracts, writing of smart contract, the logic behind writing the smart contract, you need a mathematical understanding to understand, to have an edge on how to write your implementation in your smart contracts, how to factor your logic to make it work. You see that many logics have different mathematical operations with mathematical operators like plus, minus, divide, less than, greater than, equal to. So all these are mathematical operators that help our logic to function properly in the blockchain space. So having this understanding of the basic mathematics that powers the blockchain will help you become much more effective while building and learning blockchain um, development. So reviewing some basic arithmetic, we have addition and subtraction. Addition and subtraction, uh, okay, cool. For addition and subtraction, you used to try to calculate like transactions, calculate balances of an account, calculate token transfers and the rest. So these are some of the basic um, arithmetic involved in the blockchain, getting transaction balances. Once a transaction has happened on a particular from a particular account to another account, the balances must be updated immediately, right? If these balances are not updated, there will be a problem in the calculation. There will be a problem in the transaction. There will be a problem in the history of the blockchain. There will be a problem in the block. So mathematics is what is used to power all this. That once a transaction happens, if I send tokens to one of you, that token that I sent, the same quantity of the token I sent to you should be deducted from my account balance. So if I have 500 field tokens and I send 50 field tokens to one of you in the class, 50 field tokens must be deducted from my balance. While the person that received the token, 50 field tokens must be added to that person's balance. Now, I know it sounds like, yes, that is the law, that is what is meant to happen. But behind the scene, it is math that is powering this. If you do not have basic understanding of math, you won't be able to do your computations properly. And so when you are creating your smart contract that handles maybe an ERC logic, ERC 20, ERC 725, 721, 1155, they are building an NFT or a token. If you do not implement these effectively, you would have a problem in your logic. You will have a problem in your smart contract. If you do not know how to add and subtract and where you should add and subtract from, that is is a total vulnerability that will be in your logic, and any hacker can exploit your contract. So it is very, very important that we have some basic understanding of our basic mathematics to understand to secure us in making our in defining our logic for our smart contract and every other brainstorming activity involved in working and bringing to life that idea you're building. So these are some examples: transaction balances, adding received token to an existing balance, like I just said, token transfers, subtracting tokens from a sender's balance. So this is an example. If Alice has 10 tokens and receives 5, how many tokens does she have currently? So 10 plus 5 is equal 15. There is also a but in this case. If Alice has 10 each USDT, and you send Alice five few tokens. How many tokens does Alice have at the end of the day? Now you realize that Alice does not necessarily have a few tokens anymore, because these tokens are of different types. So you have to factor that in, that a wallet address can handle and hold more than one form of token. Sorry, can you see that? Okay. So when we talk about multiplication and division, multiplication and division are used for calculations of like gas prices, transaction fee, base fee, token distribution, and all of that. So some examples are calculating fees based on data size. Now, every gas fee, every gas price differs from the other depending on the size of that transaction that the address the user is performing. And so the logic for calculation of this gas price is also in mathematics. So the bigger your transaction, the higher the gas fee. And there's a specific uh, logic that handles calculation of the gas fee for a transaction, that checks the weight, that checks the nonce, that checks everything, and executes that transaction before it is added to the block by the validator. Also, we see multiplication and division in terms of token division, that is dividing tokens among multiple recipients. So it is mathematics that is powering this, especially a simple example we know is the airdrops, right? For the airdrops, there is a there is a logic that needs to be written to distribute this airdrop according to users' performance, wallet balances performance, that tracks to see that this wallet address has fulfilled this condition, and how to uh, and the proportion of the total airdrop to be allocated to that particular wallet address. So with mathematics, this can be done. If you do not understand the mathematics behind distributing of tokens to your addresses, there will be a serious vulnerability in your code or in your smart contracts or the project you are building. Here's an example. A transaction fee is 0.1 tokens per unit of data, and a transaction has 10 units. What is the fee? Seeing this, if you just a transaction fee is 0.1 tokens per unit of data and a transaction has 10 units, what is the fee? If you do not check it properly and you don't understand that it has 0.1 tokens per unit of data, you might mix it up. So this is very, very important, as every information is very, very important while writing your logic. Because it is 0.1 tokens per unit of data, you can easily times the 0.1 tokens times the number of units of data available. This has 10 units, and when you times it, you get one token. If you have one unit, what will you get? What will be the fee if you have one unit of data? This is a classwork to us. I want to see your answers in the Telegram chat in the next 10 seconds. All right, introduction to exponents. When we talk about exponents, we are talking about a way that numbers add to themselves in a way that is not just a linear adding where you say 1 plus 2 or something. Is using this power of, raised to the power of, or the square root kind of, way of adding to a number or subtracting from a number. It is not just a straight addition or subtraction. It is like a multiple of additions and a multiple of subtractions, stuff like that. So exponents or powers represent repeated multiplications. It's not always obvious, but they appear in understanding token supply growth. So for those going to dive properly into tokenomics, you will need to understand these concepts properly. So what are exponents used for? Used majorly for token supply growth, long-term projections, and understanding compound effects. Example, if a token supply doubles every year, how many tokens will there be in 3 years if they are 100 currently? Excuse me. No one has dropped the answer to the question I asked. So you guys are not following me. No one has dropped an answer to the question I asked. I said drop the answer in the Telegram group, the 5 point orbit builders bootcamp Telegram. How many tokens will there be in 3 years if they are 100 currently? Now, if you use normal addition and you add to this in 3 years, if there are 100 tokens and the 100 tokens doubles every year, you would be tempted to say 100 plus 100 plus 100 plus 100. Yeah, experiencing technical issues. It's not tough. It's not tough. You can just type it in the Telegram as a chat. It's not tough now. You don't need any technical help to answer the question. Or do you mean you didn't get the question I asked? I asked if there was 1 unit of data at 0.1 token per unit of data. How many um, units of data how many tokens will be used up for 1 unit of data? We did 10 units of data and we sell that 10 units of data gave us 1 token, right? As the usage, the cost for the transaction. So for 1 unit of data, how many tokens will be used up? It's very, very simple, straight answer. All right, so my time is going and I have to hop up. So these are some of the basic algebra terms, variables, simple equations. We have variables like representing unknown values for x, y, z, a, b, c, all of that. We have simple equations that we use to solve linear equations. Find x if this is this and that is this, find x. So if a smart contract pays out x token and the total payout is 15 tokens and someone else receives 7, how much is x? So to get the logic, to understand how much x is, you have to place as the variable plus how much someone has received, which and then equal it to the total. With that, you'll be able to know how much x is. So with this, we know that x will be equal to 8. If you do x plus 7 equals 15, you have to move the 7 across to the other side. And once 7 is moved across the equal line to 15, it becomes 15 minus 7. So x will be equal to 8. And so now we know if we do 8 plus 7, it gives us 15. So we know how many x tokens uh, was given to was was um was given to whoever it was given to. Some practical blockchain examples are tokenomics and transaction fees, The token has total supply of 1,000 and 20% is allocated to the team. How many tokens is that? You guys do the calculation. If a token is um it has a total supply of 1,000 and you allocate 20% of the 1,000 tokens to a team, how many tokens is 20% of 1,000 tokens? Also drop it in the group. Another usage is calculating fees based on data size or complexity. All right, so that will be all for today. I am so sorry I had to rush the session because I had to hop off to another meeting by 10. I'm sorry for technical issues, but please go through the slides, ask your questions on the Telegram channel also, and I would respond to that. Thank you very much, Mr. Enoch. Over to you. Oops, I see like I kind of see I'm basically the only one on the call, so unfortunately for that, I'll be ending the call now. Thank you guys. And please go through this session again, watch the videos, subscribe to the YouTube channel, and ask your questions. I'll be waiting for your questions during the day to answer. Enjoy the rest of your day, guys. And bye for now.